Okay, so what we're discussing in last class. Yes. Uh-huh. Okay.
After that, TCP and UDP, flags.
We'll explain TCP header.
Source IP address and
IP address.
source MAC address.
MAC address. Okay, good.
And the destination MAC address.
MAC address. That's nice. Yes. Anybody? Is it a MAC address? IP address. I'm talking about TCP header.
Header.
Yeah.
Port, source port.
Port number, right? How come it is IP or MAC? Yes. Then after that, sequence number, and then mm-hmm. 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 Okay. And then reserve. Is it what the order you are telling or randomly? Yeah, continue. Mm-hmm. In TCP header. Huh? ಯಾಕೆ ಇಟ್ಟಾಗಲ್ಲ ಬಿಟ್ಟು ಬಂದ್ರೆ ಎಲ್ಲ ಬಿಟ್ಟು ಬರ್ತದ್ರ ಎಸ್ ಇಟ್ ಆಫರ್ ಓಕೆ So you didn't watch the video yesterday, right? Don't tell that I saw it lately, right? Okay. Yeah. The next header, we have IP header. Okay. So it's a IP version 4 header. Exactly. Okay. So here we have some different fields. First one is a version, and then header length, and then service type, and then total length. Okay. Version is having 4 bits, header length is having 4 bits, and service type is having 8 bits. Okay. Total 16 bits. Okay. After that, 16 bits of this total length. Yes. So it makes it as a 32-bit. Okay. After that, data identification, datagram identification, that is of 16-bit, flags just 3 bits, and then fragment offset, that is of 13 bits. Total again 32 bits. And then we have time to live 8 bits, and then protocol 8 bits, and then header checksum 16 bits. Total again 32 bits. Source IP address, that is 32 bits, and then destination IP address, that is also 32-bit. Okay. And then we have option here, that is different thing. Okay. So here, yeah, it's 160, and obviously it will become what again? 20 bytes. Okay. One second. Again, option field. Okay. Again, it may go up to 60 bytes. Okay. So if they ask you what is the size of this IP header, that is to version 4. Okay. You have to tell it like fixed is what? 20 bytes. But if you include the option field, then it may go up to 60 bytes. So minimum is 20 bytes and maximum is 60 bytes. Okay. Now we'll see one by one. What are the different fields we have that I mentioned here? The first one is a version. So I hope you already know that in IP, we have two versions. One is a IP version 4 and second is a 6. Okay. So currently we are looking at the version 4 header. Okay. So obviously then it will be specifying the IP version, that is IP version 4. Okay. Next, header length. This is going to indicate the size of the IP header in 32-bit words. Okay. Excluding that what do you call option field. Yeah. So whatever the size will be there of that IP header, so that will be mentioned in this header length, that is of 4 bits. Next we have type of service. So here this is really important. This will help us to, you will get this in only two headers. One is in layer 3 header and second is in a layer 2 header. Okay. This is used for quality of service. Quality of service. We have a separate protocol as a quality of service just to maintain the network quality. Okay. So there we use this field. Okay. Where we are going to give some priority on some data that will be mentioned in this field. It's gonna, sorry, it is used for quality of service. It is going to prioritize a specific type of traffic. Okay. For example, low latency for VoIP, that is voice over IP. Okay. Like I hope you already know that like voice will be always given as a highest priority. During the data transmission, voice will be given as a highest priority and then video and then the normal data. Okay. Why is that? Because if all the data is getting competing for the bandwidth, then the voice data may get lost. Understood? Because that's a low latency data. And if that is getting lost, then the receiver not going to receive the proper data. Okay. And voice is kind of a data that we can't transmit. Am I right? If I'm talking now, okay, if that is not audible at the other end, yes, I can't repeat the same thing every time. Am I right? So that's the reason voice is given as a highest priority in the network. And then they'll give for a video and then they'll give it for a normal data, because normal data can be retransmitted. That will be in the kind of what? Text or video or audio or something like that. Okay, but that is what retransmitted. But the voice is not like that. So that's the reason, just to give some priority to some data, we use this type of service that is of 8 bit. Okay. And then total length. it's going to represent the total size of the IP packet, that is header plus payload. You have two lengths here. Header length, this is only size of that IP version 4 header, excluding option field. What about this total length? This is including the total, what do you call, including the option field. Okay, and the payload which is coming from the upper layers up to transport layer. So that may go up to maximum 65,535 bytes. Okay, and identification, that is of 16 bits. It's a unique identifier assigned to each packet. It is useful for what? Reassembling the fragmented packets. So do you think what it is equivalent to? What do you think it's equivalent to in TCP header? It says like it is unique identifier assigned to each packet, which will help us in reassembling the fragmented data. Where you have seen, I mean, what field we have seen in the TCP header? Which field is that? What network? Field I'm asking in TCP header. Yeah. Sequence number. What it does? It will give a number to each and every fragmented or segmented data packet. Okay, so that will be helping at the destination end to rebuild it. Okay, so the same field we have in IP header also, but this is for network layer. That was for transport layer. Okay, so identification, this is what the unique identifier which is assigned to each packet. So that will be helping us, I mean the devices, receiver, to reassemble the fragmented packets. So next we have only 2 bits here, sorry, flags. Okay, I have 3 bits. One is a DF, that is don't fragment, and second is a MF, more fragments. Yes. So DF means what? It is going to prevent the fragmentation. It is going to stop the fragmentation of the data. Okay. And what is MF? More fragmentation. That means if the data should be fragmented more, in that case, this MF field will be high, or MF flag will be high. It says that it is going to indicate more fragments are incoming. Understood? So these are the 2 flags we have in IP header. Okay. After that, we have fragment offset. So what exactly it is? It's gonna specify the fragment's position in the original packet. Whatever the data we are fragmenting, okay, at exactly where we have this fragmented data, okay, in that particular packet. So that will be given by this fragment offset. Next is really important, that is time to live. TTL we say. Okay. So it is what? It's gonna define what will be the lifespan of that particular packet. Okay. If I say ping 10.1.1.2, okay, so there it will give you a TTL value. Okay. So let's suppose like can you see the TTL at the last? Can you see TTL? Okay, here it is. TTL 111. That means it can traverse 111 routers. 111 routers. Okay. It is going to define or limit the lifespan of a packet in the network. Okay. Here it is gonna hop. Hop means what? These are my routers. Okay. Whatever the number of routers we have. Yes. So, sorry. Let's suppose that packet is getting generated here on the first router. Okay. What the first router will do? It will give one particular number as a lifespan of that particular packet. Okay, that means if it is given the TTL value as 3, okay, then it can able to jump only thrice. Okay, 1, 2, and 3. This is the last router it can reach. After this, whatever the router it is connected with, it is not going to go to that router, because it is already said that this particular packet can only traverse up to 3 hops. Okay, 111 means what? It can jump 111 times from one router to another router. And if I have given this 3 as a TTL value, whenever it is going to jump from one router to another router, it is going to decrement by that, that value by 1. Okay, that means here the value will be 2, here it will be 1, and here it will be 0. Whenever it is 0, then it is considered as a, we can't take that TTL value because it can't jump. We already said that your TTL value is 0. That means you can only be in that particular router. You can't go to the next router. What is this now? Time to live. That means this is going to define or limit the lifespan of that particular packet in a network. Understood? Next is protocol. So where it's going to specify the upper layer protocol. Which is upper layer here? Transport layer. So in that transport layer, which protocol it is using? Whether it is a TCP, whether it is a UDP, or it is a ICMP packet. With the help of these numbers. These are called protocol numbers. I hope you already know that. TCP is having a protocol number as 6, UDP is having 17, and ICMP is having a 1. Okay, so using this number, it's going to identify which protocol the upper layer is using. Okay, after that, again the checksum value. Okay, where it is going to validate the integrity of the IP header. I need to explain this again. Next, we have source IP address, destination IP address, both of size 32 bits each. Okay, and where the source IP address is nothing but what? Where it is going to identify the originating of that packet or originating device. And then destination IP address means what? It is specify the recipient device. Okay, like where it is destined for. Okay, next we have option field, where it will be having it's optional, where it is used for advanced features like route recording or timestamping. Okay, if it is included, then the size may go up to 60 bytes. If it is not included, if you are not added any kind of data packet into this option field, then the IP header size may be up to 20 bytes. Okay, am I clear? Okay. Yes, online. Any question here?
No, I'm okay.
Where in total? अरे सीक्वेंस नंबर बताया था ना मैंने, टीसीपी हेडर में बताया था. इसको हम नंबर देते हैं, याद है कुछ? 1 2 3 4. ओके, इसे कहते हैं हम सीक्वेंस नंबर इन टीसीपी हेडर. सेम इसको बोलते हैं हम आइडेंटिफिकेशन नंबर इन आईपी हेडर. क्यों? क्योंकि ये तो एनकैप्सुलेटेड होता है किसमें? सेगमेंट में. ठीक है, एंड network layer is not going to open your transport layer header, that is TCP header. That's why we are giving extra, one more identification number that should be understood by the network layer, because that is also need to reassemble or rebuild that data, right? So that's the reason we are using this identification number. Yeah. So next we have Ethernet header. We have seen the layer 4 header. Which are the layer 4 headers? Layer 4 headers. TCP header and UDP header. Okay, and layer 3 header? IP header. and we have the layer 2 header. Okay, in that only they included this layer 1 header also. Okay, this is what I can say, both layer header, whatever remaining headers, two layers we have, that is data link layer and the physical layer. This is both, but we call it as a Ethernet header. Okay, this is L2 header, where it will be including VLAN header also inside this one. Okay, yeah. So Ethernet header, the actual size of this Ethernet header is 14 bytes, where it is having only 3 fields. One is a destination address, second one is a source address, and next is a length. In this case, destination address and source address means what? Which address? MAC address. And then we have the header length. Okay, or Ethernet type also we can say here. Ether type or header length. That is of 2 bytes. And both destination address and the source address having the size of 6 byte each. Okay, and other than this, whatever the fields you can see, they said to be as a physical layer headers or fields, I can say. Okay, first one is a preamble, that is of 7 bytes. Next we have SFD, start frame delimiter, that is of 1 byte. Next we have the data payload, whatever the data will be getting from layer 7 to layer 2. Okay, that will be there in this data, that is of 46 to 1500 bytes. Okay, and then we'll be having the checksum, frame check sequence, CRC. Okay, so that is of 4 bytes. So we'll see one by one. First one is what? Preamble. So what is this preamble? It is used by the network devices to synchronize a clock signal before receiving the frame. Okay, let's suppose like we two other devices. Okay, and I want to talk to you. What the physical layer will do? First, they will check the clock signal. Are we in the same parameter? Okay, are we in the same parameter? Are we able to transmit or transceive the data between the source and destination? Then what the preamble will do? It will just set or synchronize the clock signal between this source and the destination, or sender and the receiver. Okay, and after that, it is going to ensure that both sender and receiver are ready for the communication. Okay, that's what the use of this preamble. Next is what? Start frame delimiter. It is just an indicator, I can say. Okay, as I already said you. After this, the second layer header will start. Okay, so after preamble, where exactly the second layer header is starting, so that will be marked by this start frame delimiter. Okay, what exactly it is? It marks the end of the preamble and start of the Ethernet frame. Okay, where it's going to indicate the layer 2 header is begin. Yes, what the preamble is? Preamble is what? It's a physical layer header, a field, I can say. Okay, so after this, when this layer 2 header is going to start, okay, that will be marked or indicated by this SFD, that is only of 1 byte. Okay, and then destination MAC address, source MAC address, both are having the size of what? 6 bytes. Okay, and but this destination MAC address is what? The hardware address of the recipient device, and the source MAC address is what? Hardware address of the sending device. And after that, we have Ethernet type or a length. Okay, Ethernet type or length, it is of 2 bytes, where Ethernet type is nothing but what? It's going to specify the protocol in the payload. The field which we have in the IP header as like protocol, that will help us to give the information about what protocol the upper layer using. Okay, so here also Ethernet type, where it is going to specify which protocol the upper layer, that is network layer, is using. Okay, after that we have length. It's going to indicate the size of that payload. Okay, payload means what? The total size. And then the payload here, actually it's going to contain the whole data, the whole upper 6 layer data into this header. Okay, that is up to from 46 to 1500 bytes, where it is going to contain the encapsulated data such as IP packet or a ARP messages. And then we have frame check sequence, FCS, that is a 4 bytes. It's going to ensure that data integrity by verifying the frame's content using some checksum value. Okay, this is the Ethernet header. Okay, any doubt? Any doubt? Okay. If no doubt, then we'll go for IP address. Okay, what is IP? I know it is Internet Protocol. What exactly the Internet Protocol is? Why we use that one? Sorry? Unique identification for the device. Okay. But for that, we have MAC addresses, right? Using IP address, we transfer the data. Sorry?
We can locate the device.
We can locate the device. Where? Okay. Yes. Geographical location. Okay. You both got the drive access, right? Did you check it? Yes, Mr. Gopal Krishna, what is Internet Protocol?
Sorry, sir.
Uh, I would say like a human readable address which would be easy for people to relate to when you compare with MAC address.
Okay.
And it has a unique feature. It can be unique and it cannot be duplicated. And it has a private and a public part over there.
Exactly.
And there are multiple versions. I think IPv4, 5, 6 and all. I think 5 is only 5 is not used either, if I'm not wrong, experimental or something.
Yep.
6 is 6 has been adapted, and if I'm not wrong, cloud has started already adapting 6 as well.
Yeah.
And I remember a few years back when all the ISP informed that all the internet traffic will be routed for one day through IPv6.
Okay.
I mean, a few years back, I think. Right now, I think many companies have started adapting to IPv6.
Yeah, we have to go for that now.
Yeah. And it's a little bit fascinating to see that IPv4 is getting exhausted. Uh, Even though the number is very high number, but it's
Yeah,
I think
it's not a
because of
high number now.
right now it is not, it doesn't look like a very high number because
4.2
of
million.
cloud and a lot of other things, right, which is happening around mobile phones, things like that.
Exactly.
Yeah.
But I wanted to hear that one word, that it is kind of a unique identification in a network. Okay, whatever the answers you have gave, that is correct. Okay, but where you are going to locate, where are you going to identify that device inside that network, right? Yes. Yeah, for that, I mean, for identification, all we have MAC addresses. So why we are raising this IP address? For the communication, okay. And with the help of the same IP address, we are going to transfer the data from one device to another device. Okay, but that is in what? Network. Okay, it's okay. Next, if you want the exact definition, you can see here. IP stands for what? Internet Protocol. Okay, where it is an address, it's a unique identifier assigned to every device connected to the network or internet. Okay, where it is defined as it's a numeric label assigned to devices that uses the internet or a local area network to communicate with other devices to share information with a specific location using the IP address. What it is? It is a unique numeric label which is assigned to each and every device which are there in the network, which will help us to make the communication from one device to another device. Okay, and even it will help you to give the location, exact location of that particular device, where exactly it is. Okay, this is what the IP is, Internet Protocol. So in that we have two types, as Pradesh mentioned. Okay, we have that is a private IP address, and second is a public IP address. So what do you mean by this private IP address? You may say it like private means private, public means public. No? What exactly it is?
Which is usually in local
Which is used in
area.
local area network. Okay. What about public?
It is used globally.
Globally.
So
Okay. So which IP address you have to buy? Public IP address, private IP address. Which IP addresses we have to buy from the ISP if you are starting in a public?
Private.
Private.
Public, we have to purchase. Private, we don't have to, because yesterday you configured 10 dot something, right? Yeah.
Yeah, we have two types. Private IP address. Private is nothing but what? It's a address range of non-internet facing IP address, which is used inside an internal network. Okay, we have some three ranges, okay, which is considered as a private IP addresses, which we don't need to purchase or buy from the ISP. They are already defined as these are the private IP addresses, and they can used in the local area network or internal network just to make the communication within the local area network. They are not routable. Okay, if you want to go for the routing, then you have to go with the public IP addresses. Okay, that you can find it in internet. Yes, the internet can't understand this private IP addresses. It says like, I don't know who it is. I don't know who is 10.1. I don't know who is 172. I don't know who is 192. Understood? I can only understand the public IP addresses. If you have any, please come to me. Otherwise, don't. Okay, so that's the reason we'll be using a translation. Okay, we call it as a NAT, network address translation. Okay, so that's a separate part. We'll study it later. Okay, so what is this private IP address now? It's a kind of a range where they are never going to face the internet. They are used only within the internal network. Okay, and public IP address means what? It's opposite of the private, obviously, where a public IP address range is what? It's an external facing IP address used to connect their business or home internet or network to their internet service provider. Obviously, they're used in the internet. Okay, so these are the two types we have in the IP address, private IP address and the public IP address. Clear? So IP addresses are designed to allow host on one network to communicate with one host on a different network, regardless of the LAN the host are participating in. Okay, which will, these IP addresses will allow us to make the communication in the same network and in different network also. With the help of this IP address, we are going to communicate with the different devices. Okay. So next we have some points about this IP address. We don't worry, we have it. Okay. Some important points regarding this IP address. First one is what? It is also called as what? Logical address. Okay. MAC address is called as what? Physical address. Okay. And this IP address is called as what? Logical address. And it works at the network layer of the OSI model. Layer 3. Okay. Network layer is what? Layer 3. And the IP address which works at the network layer. And IP addresses will be unique in a network. What do you mean by this one? We can't say that MAC address is unique. Unique is, it's unique in the whole world. Okay, but I can't say the same thing with the IP address. Yes, you can't find the same MAC address with the other device in the whole world. Okay. But this IP address will be unique inside a network. Yes, we can assign the same IP address in a different network, but we can't do it in the same network. That's why it is unique inside a network. Okay. And you already know that we have two versions in the IP address. One is IP version 4, second is IP version 6. Yes, we had one more 5. So we are not using that one. Okay. So IP version 4, this is having the size of 32 bits, and IP version 6 is having size of 128 bits. So according to that, the total number of IP version 4 is like just 4.3 billion IP addresses. It's a very small number now. Okay, 2 raised to 32, that's nothing but 4.3, almost, it's approximately 4.3 billion IP addresses. Okay, and total number of IP addresses we have in version 6, that is 340 undecillion. It's not trillion, it is undecillion. Okay, so we'll study what is that undecillion, how many IP addresses we have. We have a separate topic on that IP version 6 later. Okay, so now you just understand how many IP addresses we have in total in IP version 6, that is 340 undecillion. That is nothing but 2 raised to 128. Okay, and these IP addresses are represented by 4 octets, and that is 1 octet is equals to 8 bits. So 2 raised to 8 is nothing but 256. Okay, how exactly we write this IP address version 4? And now one more thing, let me tell you, whatever the protocols and practicals we are going to do with the help of this IP version 4. Okay, but still, because we are still using IP version 4 only. Yes, we are adapting IP version 6, but they're not that effective now. Effectively. Okay, so that's the reason every practical will be done on this particular IP version 4 only. Yes, we are going to do the routing and all with the help of IP version 6, but only in that same chapter, not in all these protocols. Okay. Yeah, how we write this IP version 4 addresses? In a decimal number. Okay, how we write? Yesterday I've given one IP address, right? That is 10.1.1.1. Okay, how it is? Is it a decimal number, right? Yes or no? So this each will be having 4 octets here. This one is called as what? 4 octet. Within that, we'll be having 8 bits. We'll be having 8 bits. So here also we have 8. Here also we have 8. And here also we have 8. So how many? 32 bits. So what is the size I said? 32 bits. Okay. So how exactly we write that one? So if I take only one octet, in a single octet, we'll be having 256 numbers. How many? 256. Okay. But we write it as 0 to 255. That means the least number is 0 and the highest number is what? 255. We don't cross this 255. If you cross this 255, it's an invalid number in the IP version 4. Understood? So you can see here 8-bit, 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 8-bit. So 0 to 255 total is nothing but 256. So that means in a single octet we'll be having 0 to 255 dot 0 to 255 dot 0 to 255 dot 0 to 255. And we separate this octet with the help of this dot. Okay, we use this dot to separate the octets. How many octets we have? 4 octet. Okay, total size is 32 bits. Okay, so like that we have 4 octets. In a single octet we have total 256 numbers. That is 0 to 255. Am I clear? Sure. Okay. An IP address consists of 32 bits information, and these are divided into 4 sessions or segments or octets, I can say, referred as a octet, or bits with each containing 1 byte or 8 bits. Okay. And this IP address is also depicted in 3 ways. Okay. One is a decimal or dotted decimal method that we currently use. Okay. That is 172.16.0.1. This is called as what? Dotted decimal method. And you can write the same thing in binary also. Okay. That is called binary method. And you can write the same thing in hexadecimal also. Okay. That is called as what? Hexadecimal method. So which is better? Writing that into binary or hexadecimal or decimal method? Decimal method, because it is easy to remember. Okay. It's not really easy to remember this binary number or even the hexadecimal number. Yes, you can assign the IP addresses with the help of these two methods, but that's not feasible. Okay, so that's the reason we always use this dotted decimal number or method, I can say. Yeah, clear? Great. So these are some terminologies. You already know that. Bit means what? It's a one single digit. It may be either 0 or 1. Okay. Byte means what? It's a set of 8 bits, or we can say that also as a octet. Okay. Now, what do you mean by nibble? Have you heard about nibble? Group of bytes? No. 4 bytes? No. No. Yes, online. Anybody? What do you mean by nibble?
It's 4, right?
4?
Nibble, I think pairs of 4 or something like
4
that.
is correct. Next is what? Bit, byte.
Uh, I don't recall.
Okay. Bits. Are you sure? Right there. It's bits. Okay. 8 bits is called as what? 1 byte. 4 bits is called as what? Nibble. Okay. Just for your and knowledge. Okay. Nobody uses nibble. Next, we have network address and a broadcast address. So this is the actual IP address started here. Network address and a broadcast address. So understanding these two is really important. Yes. So what exactly the network address is? This is a designation used in a routing to send the packets to a remote network where all host bits will be 0 except network bits. For example, 10.0.0.0. Okay. Whatever the 0 you can see, they are called host bits. Other than 0, what you can see the whole number, that is called as what? A network portion. Okay. And in second one, that is 172.16.0.0. This is called as what? Network address. Good. Great.